It's after lunch, so I hope you are not too heavy. So I'm calling also to the stage Dr. Apostolos Chondronasios, our Director of Engineering, Christina, Vlasi, Senior Data Scientist from us, and Meriem, Jerbi from BORG Automotive, Business Development Advisor. I remember it. I was confusing it a lot. So, you have been listening a lot about it. I will try to rephrase it a bit. We are in a revolution. Not Industry 4 or Industry 5 and the age of thinking, of how you turn data into information, into insights, into knowledge. But now we are in the age of action. We are moving away from the smart thinking factories, and we are going towards the autonomous ones. Why autonomous? Because they will not only think, they will also decide, and as we saw before also, and they will act on their own. And Agentic AI is the way that we will get there. And if you look around nowadays, AI and Agentic AI is everywhere. It takes over, I think, most of our daily tasks and daily routines, work-related and personal-related. Okay, but why a revolution? Because right now, we are in a crisis of complexity. The promise of smart factory turned out to be a chaos. And why chaos? Because we have too many systems for too many different things. We have one system for quality, another for production, another for maintenance. And all these systems are silos. They are totally disconnected. They don't communicate with each other. They are not modular, they are not scalable, and non-interoperable. So if you want to add something new, it's a headache. And why a headache? Because it's a new procedure, it's a new training, it's a new software, another dashboard. So what I'm trying to say is it's not working. And these systems are really important. And why they are important? Because they collect data, loads of data, mountains of data. A single modern factory produces 1 petabyte every year. If you are not familiar with petabytes, it's 1 million gigabytes. So what does it mean? We are collecting data from almost everywhere, and we have been measuring almost everything. Yet, we haven't achieved that much as we already seen, and the reason behind it is because we use only 20%. Only 20% is being used for any decision-making. The rest 80% is dark data, leaving the factories literally in the dark. So the problem is that it doesn't come without a cost. 92 billion every year, Europe and UK alone. This is the unexpected downtimes. So the inability to connect all the shop floor data with business logic, break down these silos, has turned out to spend 10.5 million, I did the math for you, every single hour. So the problem is not that we don't have enough systems. It's not that the systems that we already have are not working. We need a different paradigm. What we need is action. And how we are going to make it? With Agentic AI. Agentic AI is an enabling technology that solves, as you already listened to, many of our interoperability issues and make things simpler. It's scalable, modular, and so on. So, okay, but why Agentic AI and not traditional AI? Let me put it like that. It's a different design. Traditional AI is designed to have intelligence, consume a lot of data, massive data sets if possible, to give you patterns, to give you insights, to give you information, to give you predictions. And they are great at it. But they are passive. They don't tell you what to do. So imagine have all these different dashboards, having different decisions, different predictions, conflicting with each other. So the question is, what am I supposed to do with this information, right? And here comes Agentic AI. Agentic AI connects all the dots, helps you to not only get answers, but get actionable answers and actionable suggestions of what you could do. And what is Agentic AI? Let me put it really simple. It's like your travel agent. You just give an objective. I want to travel to this location, 2 individuals, this area. I like walking, I like sightseeing, museums, and my budget is like that. And they do all the work on your behalf and give you some suggestions, and of course, then you can buy. This is how it will look also to your factory. So they will take all these automation hierarchy levels, the different systems that you may have, and they connect all the dots and combine all the multiple information into an integrated intelligence. So at the end of the day, what you will achieve? You will achieve to have a conversation without adding an extra dashboard. Have a holistic view of your factory and discuss and get actionable answers and actionable suggestions. So to the question, okay, Nikos, really interesting, but how do agents look like? I'm sorry I'm talking, I'm not available. And how do these agents operate? I will call to the stage Dr. Apostolos Chondronasios for our first demo today, an agent without a chat, because not all agents need a chat. The floor is yours.
Thank you, Nikos. All of you are familiar with chat interfaces. Many of you, I think, have used ChatGPT, Claude, and so on, but not all Agentic AI is built like a chat. So I want to show you an example of an agent that operates without a chat interface. In Core Bit, our product, zero complexity is our philosophy. We want to take away the burden of operating through multiple dashboards from the engineer to assist him in the decision-making. So for this reason, we have developed an agentic system, which I will show you today. But first of all, what is Core Bit? What is our product? Core Bit is a predictive maintenance platform, and it connects to your shop floor using hardware devices, collects data in real time, operating 24/7, while deep learning algorithms calculate and predict the health of your machines. Those agents provide you with insights about the degradation of your machines and alert you through email and notifications. So it's a whole platform that spans from the shop floor to the cloud to your mobile devices. So for this reason, when an alert is generated, we want to provide you a report that will provide explainability and recommendations to you. And how do we achieve this? For example, this is a snippet of our interface. Our agent, our system grades your machine's health in different steps. So when your system from normal degrades and goes to warning or critical states, a button appears there, and if you click that button, a whole process is commencing underneath to provide you a report. But before we arrive at this point, we have to state how the problem was before to generate such a report. So this is the expert's burden, let's say. This is a complex process for which a data scientist or analyst has to go through file downloads or write code, interact with databases, and then structure the data, analyze them in the time and frequency domains, check for patterns, then consult his intuition knowledge or manuals documentation so that he can know what happened and what needs to be done. He then writes a report, and at the end, he has to submit this report. So obviously, this is a very boring process for any engineer, and it can take from 4 to 8 hours, depending on the skill level of the engineer. So how can we solve all of this with Agentic AI? What we have done is we have grouped some of those processes. We have developed traditional software along with specialized agents, and then the process is transformed into an agentic system, which is orchestrated by an agent orchestrator and is a sequential process, where the orchestrator commands the first agent to retrieve the data, the other agent to analyze the signals in the time and frequency domains, the other agent to retrieve the knowledge from the database about your machine, your asset type, and so on, and then the final agent, the technical writer, to produce the report. And the whole process takes only 3 to 4 minutes. And the best part about that is that you don't need to be an expert to perform this analysis. Any operator, be it the manager or any technician, can click on the button and have a report ready. So this is the final report. It's a structured document with explanations, with tables in the time frequency domains, graphs, and It provides the why and what do I do next when an incident happens in my factory. So you have seen an agent that is not just a chatbot. It's a simple button. The process is invisible to you. And think of it as a colleague that operates beside you. We have prepared a very short demo in Accelerate Timeline, so you can see how simple the process is. This is our interface. There is a clock overlaid. So from starting the process to clicking the button and submitting the sequence to commence, until the final report, it only takes 3 minutes and 31 seconds. So this greatly enhances efficiency. It accelerates decision-making in the shop floor. And there is a flip side to that. The flip side is that sometimes you need to dig deeper. You need interactive knowledge discovery. And then you will need something more like a chat interface. Usually what you had to do is go through file cabinets, get printouts of the machine's manuals, or search the file system, or scroll through 300-page PDFs. But now, with our agentic system, you can also have all the knowledge of your shop floor indexed and available to you in under 10 seconds. So I have showed you 2 examples, one of a simple agent behind the button, and another a more traditional chat interface for it.
Thank you, Apostolos.
Thank you.
Okay, I have to be honest with you. I tested the system and asked something about the manual, and I didn't understand the reply, so maybe it's my fault. So I presume you need also the type of expertise to use it. So thank you, Apostolos, again. Now we are going to see a remanufacturing guidance system. So it's an agent, and this is 2 ladies that will present you. It's Meriem and Jerbi from BORG and Christina Vlasi. So now you will listen from the industry challenge, what they are facing, and why we are here today for this solution. So Meriem, the stage is yours.
Thank you. Thank you very much for the introduction and for the invitation. Hi everyone, I hope you hear me well. Everything? Okay, now it's good. So hi everyone, I'm here to introduce with Christina the solution, but before that I would like to introduce the company and remanufacturing itself. I don't know how many people maybe are familiar with remanufacturing, maybe you can raise your hand if you are. Okay, good, we already have some people who are familiar, so that's very nice. So I'm here representing BORG Automotive Reman, so we are the biggest independent remanufacturer of automotive spare parts in Europe. Our mission is to give new life to vehicles with sustainable solutions, basically moving from what we call a core, so used unit like you see on the left of the picture, and bring it back to like a new condition. So this is what remanufacturing is. The company today is more than 2,000 employees. It's a Danish company, part of a conglomerate active in the stock market in Denmark, and as an idea, it's more than 200 million euros in revenue in 2024. We are mainly focused on the independent aftermarket. Actually, we only serve the independent aftermarket through our own brands. You can see them, GRI, Elstock, Lucas, or TMI. Maybe you know some. But we also have customers who are OEs or tier ones, which we sell for in private label through our company CPI, and we also have new production, but this is not the focus today. And as you can see here, the production is in-house, so fully in-house. We're serving the European aftermarket, and we have also footprint in Africa, in Tunisia today with a factory. And these are, as you can see, the products that we have in our portfolio. Now, to focus on the reman process and what it looks like, the reman process is an industrial process starting with a full disassembly of a product, so a used unit that we take back. Then we have, which is the key step, the cleaning. We're not talking about small cleaning, this is really industrial cleaning with different steps. Inspection of every single unit and sorting. Then some units are reconditioned, so we're talking about the sub-spare parts of the units. Some are completely replaced automatically, especially, for example, wear parts. And then we reassemble the product and we go through a final testing with every single unit This is a functional testing that we have at the end of the line. And here we're talking about remanufacturing and circular economy. So this is a circular business model. So we have the forward logistic where we distribute our product through a distribution chain. And then, so our customers are mainly big distributors and buying groups, for instance. We have also some small distributors, but it's mainly, let's say, at the top of the value chain. And then these distributors will sell to the garages, which are our end customer. But now what's complicated and really complex is the reverse logistic and taking back the cores, so the used units, because we need them as raw material, let's say, to remanufacture them. And for that, it's the garages that send back to the distributors the units that have been used. We're talking about units mounted in cars for like 15 years on average. And then they come back to us to be remanufactured. And this is quite complex. In remanufacturing, of course, we have some waste in that because of damaged units, for example, that cannot be remanufactured. So this is one of our biggest challenge. And usually, when we see here the origin of the cores, it's 60–70% comes directly from our customers. So the garages who send to the distributors who send us the units. But because of these problems of damaged cores, for instance, we need to purchase some of them. And for that, we need to retrieve, to find a way to retrieve easily the cores and to make it less complex, this process of collecting the cores. For that, we use a deposit system. So to incentivize, let's say, the garages to send back the cores. So we ask for a deposit for that. And so that when the deposit, let's say, when the core comes back in our factories, then we either give back the full deposit if the core is in good condition, or we give back partial or non-deposit for that. But in numbers, we have more than 2 million cores that are processed per year, with more than 10,000 garages that are in the loop. And the processing time for this deposit is on average 1 to 2 months, which is quite long. As I said before, we don't know the condition of the cores until they arrive, and we ask for this crediting from our customers. So we have imbalanced, let's say, cost and returns in this process. And we want to find a solution for that, a solution that makes it transparent for our customers. They know directly what, when they take back the unit from the passenger car, they know directly what the deposit will come back. If the core is in good condition to give back, we need decreased uncertainty. And for that, thanks to that, we would achieve 35% in cost reduction because of this long process. So yeah, the goal here is really to speed up the process. And for that, I think Christina will be the best person to show you how we did that thanks to core innovation.
And I think that you can hear me. Perfect. So we are collaborating with BORG in the Human project, and we have understood the challenge. And we are thinking, what does BORG need? So BORG has two sides, the customer, the garage side, and the BORG staff side. They need something for visual inspection, something for crediting, for the deposit pipeline, something for the paperwork, and of course, something for validation. And also, BORG staff needs something for the final assessment. The traditional approach was to develop each of these components individually. And of course, this approach works. But for who? Let's say that we start with the development of a model, a vision model. But a single prediction, a single inspection does not address the challenge. We need more. We need a crediting engine and a place for the user to fill information, and then another one place, a tab maybe for the validation, then another tab for the final assessment. But with all of this, a single user will have to check too many screens, too many tabs, with disconnected and confusing information. And this leads to fragmented decision-making and slow action. So are we building a proper solution or just adding complexity? And just think about the volume we mentioned, 5,500 per day. Okay, so we definitely need something else. Instead of building another complex system, we built a smart one based on Agentic AI. Modular, scalable, with integrated intelligence, where agents can collaborate, providing guidance, support, and meaningful insights. And let's see how this looks from the customer side. First of all, let me mention that the agentic approach is visualized in order to demonstrate to you the agentic process at each step. The guidance agent guides the user at every stage and also plays the role of the coordinator of the system, coordinating the other agents. The process begins with the user add the core ID or scan the QR code. In step 2, the vision agent comes into play, ready to inspect any kind of damage or missing parts. From step 2 to step 4, the system receives images from different components, pulley, cover, casting, and the vision agent validates the condition and also checks if we have received the correct component at each step. After this, the validation agent validates if the system has received all the required information in order to proceed with the final assessment. For the last step, for the final assessment, vision, crediting, and assessment agent collaborates in order to provide to the user the final assessment. Once the user confirms and proceeds, the reporting agent takes the lead and generates the final report, sends an email to the user, and also records the order to the BORG staff side. After this, the customer is ready to proceed with another assessment. Proceeding now with the BORG staff side, we can see the two sides fully connected and the order recorded. The only thing left to complete the process is a simple click and scan to provide proof once the core is received. And of course, here we have also the reporting agent and the guidance agent, because we don't provide a simple dashboard, but an interactive interface to support the user. So, what we achieve with the agentic approach? Fragmented to become connected, reactive to become intelligent, and uncertainty to become clarity. And with this agentic architecture, we have a system modular, scalable, able to be adapted to the end user's needs. And if you haven't seen the demo yet, please come to the demo area and explore it yourself.
Bravo. Thank you, Christina. Thank you, Jerbi. Thank you, Apostolos. Just to mention that this agent, we don't have a fancy name yet, we will maybe figure it out, is part of the agentic framework that we have been building in core for smart manufacturing. So this is part of the circularity agent. You've seen a glimpse from the maintenance agent, and we are also building a production and energy agent so that everything is connected. So thank you again. And can we accept a few questions? Yes. Well, I think we can afford it. Any questions?
Any questions? Okay.
Crystal clear. So, okay.
Well, I have one, but let me ask you questions, so I'm a little bit shy.
Yes, please. Wait for your... It's the mask from before. You've met him.
I said that I was a little bit shy to ask a question again because I'm the only one and people don't like those asking questions. But, okay, seriously, you pointed to a very real problem of over-engineering. Many new developments fail because of over-engineering. Because, you know, we like to play with the tools and it's such a nice feature, and at the end of the day, we create an elephant no one wants to use. So how exactly did you try to avoid over-engineering trap?
Sorry, this is for Apostolos? Oh, for whom is the question?
For the lady to the right, sorry, I forgot your name.
Okay.
Meriem.
Okay. Ah, Meriem. Okay.
You're talking about the agentic AI.
Yes.
For that, I will let, because Christina is more
Yes.
prone to answer this.
When you mean for engineering, you mean that?
That you try to put, you mentioned during your presentation that you tried not to make a too complex solution. How did you do it? Just by sitting and thinking, or consulting someone, or some method else?
What we try to do is to create a simple interface able for the user to guide the user at every step. So we want to transform the real knowledge of how to evaluate an alternator and component and to guide the user through this, because it's a simple person in a garage, let's say. So at each step, it's not important to check, okay, now I have to check a model, and now I want to check the crediting engine to estimate the crediting, and after what I have to do. So with this approach, you have steps, and like an interface that guides you every time and explains you if you have something wrong.
This is clear. I can imagine a simple person in a garage in Poland.
May add something also to that. Throughout the process of developing this, there's been an exchange between, Core and us. It's part of this is part of a research project, Horizon Europe. But also, this came from a feedback from a customer, and I think you mentioned the importance of listening to feedback from customers related to that. So
that was my question. So, did you have such people involved in the process, say at the beginning and at the end, or were they part of the team?
We had surveys internally with garages and customers. For our distributors, the biggest burden in the reverse logistics is this lack of crediting transparency, let's say, one of them. So based on that, this is how we thought, okay, we need to develop something to solution that. And then the process went by. I think now the next step is also to test it and to see how it's received within the garages, because this is still not really, let's say, used currently within our network.
Just to mention that you can all visit the demo area afterwards in the break and see it in action, because you can take the tablet and use it and see all the steps and how the system guides you, even if you are not really trained to do it. So that's the case. So thank you again for the company. Thank you.